Today we're going to learn about section 5.2, evaluate and graph polynomial functions. 5.2 is a lesson, a short lesson that we're going to use in combination with 5.8. It's just talking about how to graph them, and we skipped over it. We went from 5.1 to 5.3, but we're kind of coming back just to show you graphing polynomials and functions. Polynomials are monomials, or a group of monomials, when you add them together. So a polynomial is something like 3x squared plus 2x minus 4. Well, that's a trinomial, but it's a polynomial. It has several parts to it, several monomials. A polynomial function has very specific rules that you need to know. Obviously, if it's a function, it looks like f of x or y equals a whole bunch of monomials here. But there are rules. One of the rules is that the exponents must be whole numbers. All the exponents must be whole numbers. That's very important. And the other thing about it is the coefficients must be real. So the coefficients must be real numbers. That's very important to know. The synthetic substitution is another way of, it's an alternate method to evaluate a polynomial function using fewer operations. And I'll show you that later. It might be something you like, it might be something you don't like, but it's really a lead-up skill to synthetic division, what we'll be doing later. So, you know, we've already done synthetic division at this point, I guess, and so you will have that skill. End behavior is how a graph ends. So a graph might do something like this, loop-de-loop, and then it shoots out here. The end behavior is how it reacted here and here. So we'll say things like its end behavior was it went to positive infinity on the x and positive infinity on the y. Or it went to negative infinity and negative infinity. That would be the end behavior. In example 1, it says decide if these are polynomials or not polynomials. If you look at the first one, it's not, right? We used to have not when I was a kid. That was the best thing in the world. You tell a girl, I love you, and then if she wasn't going to respond, you just say not, and then that was like negating everything you just said. So not is perfect. You'll notice that it's not because this is not a whole number. It had to be a whole number. And in B, this is a polynomial function. It's everything I could want. I have whole numbers, and this is a 1 right here, right? Whole numbers for exponents and real numbers for my coefficients. So it is a polynomial function. Checkpoint, you tell me, is this a polynomial function or not a polynomial function? Take a moment, pause the video. All right. Hopefully you decided that it was. It has whole numbers. So we're going to go with is on that. It's a degree 4 polynomial because it's the largest of the polynomials. So degree 4 we would say. And it's a quartic having 4 parts. See, there's a binomial, that's 2 parts. Trinomial, that's 3 parts. And then a 4-part would be a quartic. I don't really expect many people to be able to know that, but that's called a quartic. If it has 4 parts, Q-U-A-R-T-I-C. And it has a leading coefficient if it was written in proper form of -3. So you put the highest. When I ask you what the leading coefficient is, it's not -2, even though you might think that. It's -3 because it has the highest exponent. Synthetic division is, I don't know if you're going to like this or not, but I'll show it to you. Use it, don't use it. Totally up to you. Descending order. Write the coefficients of f of x in order of descending exponents, meaning 4, 3, 2. There wasn't a 1 here, but there's a 0. And that's important to note that there's not a 1 there. So when you set this up, write the value of x to the left. So the value of x is 2. So I'm going to write that right here to the left. Bring down the leading coefficient. So you see how I have it 2, 3, negative 6, 0, because there's not an x to the 1, so it must have been 0x to the 1, and 3. Watch this. We drop down the 2. That's the first step. We multiply the 2 by the 2, and we put it right here and make it 4. We add these, and we get a 7. 2 times 7 is 14. I add these, and I get an 8. 2 times 8 is 16. I add those, and I get a 16. 2 times 16 is 32. 32 plus 3 is 35. I do not expect many people to utilize that. Just another skill to have. Another tool for the toolbox. End behavior of a function. This becomes sort of important when you're graphing things. You got to know what the end behavior is. The end behavior of a function, and if it looks like this, if a sub n is greater than 0 and n is an odd number, so you have an odd degree and this is greater than 0, so it's not negative, then f of x will head towards negative infinity as x heads towards negative infinity. So it's going to be down here when it starts. And it will head towards positive infinity when x heads towards positive infinity, so it's going to go up here. And then it'll do something in between, like a curve or something. If a sub n was less than 0, meaning the leading coefficient was negative, then it would be just the opposite. It would be flipped upside down. And so as it went to positive infinity, as this went to negative infinity, it would come from over here now. It would be completely flipped. And it would end down here, where as the f of x value here would go toward negative infinity as x went to positive infinity. See how that's going to negative? The y is going down, but the x is really going up, right? And on the next one here, if a sub n was greater than 0, but n was an even number, and that's a big difference there, it's going to go to positive infinity on both sides, positive infinity. And let me show you that. Let me show you what that looks like. Think of something that has an even power like a parabola. It's heading on the y's up and up. But when a sub n is negative, it's going down and down. So maybe that's information you might want to know. Let's take a look at example 3 here, and we're going to graph example 3. When I look at graphing example 3, I hope at this point most of us are pulling out our graphing calculator. So I'm going to throw my graphing calculator up here. Turn it on, go to my y equals menu, and I'm going to put in negative x to the third plus 2x squared plus 2x minus 1. Remember, you can always rewind if I went a little too fast for you. And if I graph this thing, if I just hit the graph button and see what it looks like. All right, just let me show you my window real quick, just a basic window. If I graph this thing, it looks just like this. Well, that might not help me on a test to have that picture. So what I'm going to do is I'm going to go to my table, and my table looks like it's all set up for me. If my table wasn't set, I could go to table set. And where do you want your table to start? -3 looks pretty good. Go in increments of 1. Yep, I'm going in increments of 1 over here. So when I go to table, look at what I got. I can fill in all my blanks. 38, 11, 0, -1, 2, 3, 4. And then I just graph each of those points and I draw a nice smooth curve through all of those points. It looks like it's a third degree polynomial and is the leading coefficient is negative. So if we look to the rules about a negative leading exponent, a negative leading coefficient but an odd degree, then f of x goes positive as x goes negative, and f of x goes negative as x goes positive. So let's see if that makes any sense when we look at our graph over here. When we look at our graph, see, it was up here. Let's try to draw that real quick. It went down, through here, up, and down there. And my end behavior was that it went on and on in those directions. All right, you guys go ahead and try to graph a couple of things on your calculator. See how you do, and come back in about 2 minutes. Okay, hopefully on the first one there, when you evaluated that, you came up with negative 29. And the second one, when you graphed it, I hope you had a picture that looked a little something like, let's see how good I am drawing with this thing, a little something like that. And we can talk about that tomorrow. Thank you very much, folks, and have a great day.